Okay, so to find the radius of that circle that contains that arc, which we're going to pretend the whole circle is there. And we're looking, of course, first thing we're going to find is this piece here, x. It would be from that chord all the way to the other side of the circle. What do we do to find that? Perfect. This fits, this splits that chord in half, so it's 12 and 12. So yes, it's 12 times 12 divided by the 9 gives us x, which is 16 inches. So since x is 16 inches, tells us the diameter, 16 plus 9, 25. The radius is 12.5. Not bad at all. Well, I want to see how much you're remembering on these. Last quiz we had, we struggled a little bit on something like this. If we have, 1,728 square inches going into square feet, or if we had 4,800 square centimeters going into square meters, or 0.27 square meters going into square millimeters, or 108 square feet going into square yards. I'm going to have you test those quick. See if you can get all those 4 of those, and we'll talk about them in a minute. Okay, so number 1 up here. 1,728 square inches. First, our square inches will go on bottom, square feet on top. What's the relationship? Anybody? 1 square foot is 144 square inches. So the square inches cancel out. 1728 times 1 square foot is 1,728 square feet. Over 1 times 144 is 144. That divides to make 12 square feet. Any questions on that one? Yep. 4,800 square centimeters to square meters. Remember, we've got meters, decimeters, centimeters, and millimeters. And we are going here from centimeters to millimeters, which is 2 spots to the left, but this is squared though. So every spot on the chart is double, is 2, so it's 4. Figure 1, 2, 3, 4. That is 0.48 square meters. Remember, when it's squared, you got to go 2 decimal places for every spot on the chart. It's going to be 3. So in this one, 0.27 meters squared to millimeters squared. So we're going from meters to millimeters, which is 3 spots to the right. Decimal has to go 6. So go 1, 2, and then we got to add zeros. 3, 4, 5, 6. So it's 270,000 square millimeters. Over here, 108 square feet. So our conversion factor, square feet go on the bottom, and we're going to square yards. Our relationship is 1 square yard is 9 square feet. Good, 3 by 3. Square feet cancel out, and I'm going to take a shortcut. 108's on top and the 9's on bottom, so we're just going to divide. It gives us 12 square yards. Any questions on those? I'm going to try this one. Find the area, just the area, not perimeter, of that shaded piece. I'll give you a few minutes. Okay, so we're going to start by finding the area of that sector. To find the area of the sector, of course, we're going to find the area of the whole circle, which is pi times 20 squared, 1,256 inches squared. That's the area of the whole circle. To find the area of the sector, we need to know that angle right there. What's it going to be? 60 degrees. And we know that because all three sides are the same. 20, 20, and 20. And if all three sides of the triangle are the same, all the angles are 60 degrees. So that's 60 over 360, which is going to give us 209.3344 square inches. So that's our area of the whole sector. Next, we have to find the area of that triangle so we can subtract. To find that, we're going to have to find the perimeter because we don't know, we don't have any height or anything like that. We don't have any perpendicular dimensions. So our perimeter is 20 plus 20 plus 20, or 60 inches. Then we find our semi-perimeter, which is 60 over 2, or 30 inches. And then our area is the square root of 30 times 30 minus the first side of 20 times 30 minus the second side, which is also 20, times 30 minus the third side, which is also 20. 10, 10, 10. Yep. So second square root, I'm just going to do 30 times 10 times 10 times 10 is 1,000. You get 173.21. So 173.21 square inches is the area of that triangle. So the area of our segment there is 209.44 minus 173.21, which is 36.23 square inches. What do you think? Think it sucks? Oh, come on now. Positive thoughts. You can do it. So break it down, find the area, and I want both area and I'll ask perimeter on this one. Probably the key to this problem is finding that dimension there and finding the radius of that circle and realizing that radius goes in every direction. Radius of the circle is going to be the first thing we find. How do we find it? Or what is it, I should ask? Radius of the circle. What's the radius? It is 6 inches. Because we had 20 inches total across here, we have to have 20 across there. So that has to be 6, which of course means it's 6 inches in that direction as well. So that's what allows us to find this dimension, which has to be 4 inches. Very good. Here, well, we've got 4 and 8. So that hypotenuse, 4 squared plus 8 squared, then you just square root it, right? So 8.94 we'd have to go with. So for perimeter, we got to do the circle here as well. That's going to be pi times 12 divided by 4, right? Because it's a quarter circle. So that's going to be what, 9.42? So our perimeter, we'll start out with the 12 here. 12 plus 8.94 plus 9 plus 14 plus 9.42 plus 7. So what is that? 20, 29, 43, 52, 69, 70 point what? 60.36. Something seems off there yet. Not that I don't trust you, but it is 60.36. Okay. I'm screwing something up in my head then. Yep. Okay, so that's our perimeter, and that is, of course, inches. That's not so bad. Area, the easiest way for me to do the area of this would be to fill this in, make it a full rectangle. That rectangle is going to be 20 by 13, which is going to be 260 inches squared. From that, I'm going to subtract this 8 by 4 triangle. So it's 8 times 4 divided by 2. It's going to be minus 16 square inches, which will be 244. And then this quarter circle here, which will be pi times 6 squared divided by 4, which is going to be 28 point what? 26? That works. So we subtract that, which is going to give us 215.74 square inches. Good. Any questions? A lot. Well, I think you guys are ready.
Yeah. I was hauling ass in my I went down D and jumped on 30th Street there.
What are we doing?
All sorts of fun.
Drawing pretty pictures.
Obviously, you're not going to find it so pretty.
Look at monkey's cross. It's really expensive.
Kinda. That's my job. If you leave here still feeling good about yourself, I haven't done my job. If your friends and family still recognize you, I need to pick up the pace a bit. This is actually an extra credit question. I'm going to give you guys a few minutes to copy it down. Find the area that it's right in front of Tiger. Try and grab it. Or Robin. It's the one that's kind of folded up there. The next room should be empty for you if you want to go start working. $50 millimeters by 50 millimeters. I'll let you copy this down. We're not going to take time to work on it right now, but it is an extra credit question that you will get to Anybody who can give me the correct answer for this on Tuesday is worth up 10 points of extra credit.
Are we supposed to be finding the area of the blackened out stuff, or is that supposed to be subtracted?
The blackout stuff in there.
We gotta figure out what is trying to think here.
Okay.
Yes.
Well, there's parts that are colored in, and there's parts that aren't colored in. You could be trying to find the area of the white.
Everybody got drawn out? Okay, perfect. As long as you get the picture. My artistic skills aren't real great either. Those should all four be the same. So what we have here is going to be 20 feet, 40 feet, and 20 feet. Overall, 300 feet. Yeah, I will. No extra charge for the extra zero. Bless you. Find the area of, if I had colored inside the lines, find the area of the yellow piece there. Assume that I stayed inside the lines. Nope, this is what we're going to do in about, I want you to look at it, see what you can think of. Then we're going to do it in about 2 minutes. Okay, to cut this one up, we're going to cut the round pieces off the ends, right? So now we've got a rectangle right here that is 20 feet by, where'd you get 200? Okay, you're close. This is 20 here, right? What's this distance here? That's 20, half of the 40. There's got to be 20 here. It's got to be 20 here. So it's 20 and 20. That radius is 40. So this amount is 40, which means it's 40 over here as well, which makes that 220. Okay. So that's 4,400 square feet, right? Well, there's another 4,400 square feet for this one. We need to find the end pieces here. Well, if I look at those end pieces, what they are, if I cut them off and then put them back together, it's a donut, basically, right? It's like a washer. Better. Outside radius is 20 plus 20, which is 40. Our inside radius is just the 20. To find the area of that ring, basically, we find the area of the big circle, which is pi times 40 squared. 5024, yep. Then we find the area of the small circle, which is pi times 20 squared, 1256, which is going to give us 3,768. Is that correct? Yes. So we add that 3,768 to our others. (12,568 square feet of area. Not so bad. That there's more. Well, this here problem is a typical problem where not only do we have to cut it into pieces, but it's much easier if we take some of those pieces and put them back together. You know, a similar problem might look like this. Where I might give you, let's say this dimension here, I'm going to give it to you as 96 feet. And from here to here, I'm going to give you as 80 feet. Find the area of that. Well, here's one where you might be tempted to find the bigger area and subtract it out. If it's extra credit, I'm not going to look at it. So subtract it out. And it's very possible to do that. But I would think this one might be a little easier to break into smaller pieces and add them up. Now we're going to have to assume, by the way, that 80 and 90 go both directions, or this isn't going to work real well. But here, what I have is in the middle here, I have this piece that is 80 feet by 80 feet, which is 6,400 square feet. Then I also have these pieces here, which are how big? They're 80 here by, what's this? 8 feet, good. 96 minus 80 is 16, and we got to split that to both sides. So those are 80 by 8, but there are 4 of them, which gives us the 2560 square feet. Now then, these pieces here, each of them is a quarter circle, but I can put them together to make one full circle. There we go. So we've got pi times 8 squared is 200.96. 0.96 square feet. 0, 6, and 9. So 9,160.96 square feet. So I want you guys to try one here. If this dimension here is 40 inches, find area and perimeter of that shape. Okay, area and perimeter here are not nearly as tough as they look. The area, we have two pieces. First of all, we have that square, 40 inches by 40 inches, which is 1,600 square inches. Second, if I put those circles together, pi times 20 squared, then times 2, because there's 2 of them. 2,512 inches squared. So all it was is those 4 half circles made 2 complete circles. So I found the area of one circle and just multiplied by 2. So 4,112 square inches is the area of that. The perimeter is the circumference of a circle times 2, because it's just 2 full circles all around there. So pi times 40 times 2 is 251.2 inches is our perimeter. So there's one that looks tough, but really isn't so bad. I-beam. Your mind might be in the wrong spot here for the morning. See what you can do for the area of that. I'm going to give you a couple minutes and we'll go. If you try to cut this one into smaller pieces and add them up, it becomes a nightmare because you're probably going to be cutting, like that. That's a lot of pieces. But if I just treat this as a big rectangle here that is 20 inches by 16 inches, 320, gotta get rid of that extra 0, inches squared. And then what I have here on the sides are trapezoids. This is 10. This is 16. This is 7. So that is 10 plus 16 over 2, because you're averaging the bases, times 7, and then times 2, because there's 2 of them. So 10 plus 16 is 26. Over 2 is 13 times 7 times 2 is what, 182? That's right. 182 square inches. So we are subtracting 138 inches squared. Is that what you guys got? Perfect. As you're seeing here, what matters is being able to figure out how to cut them apart. And we could have, like I said, we could have cut this up Took a rectangle off of each end and cut triangles out with a big rectangle in the middle. We could have cut those pieces out and added them up. We would still get the same thing. This piece on the end, that is 2 inches by 16. That's 32 times 2 is 64 inches squared. This one in the middle is 2 inches by, that's 16 as well. That's another 32 square inches. These triangles are 3 inches by 7 inches each, right? What I would do with those, though, is I would take 2 of them, put them together to make a rectangle. So it's 3 by 7 and 3 by 7. They're just 2 rectangles. 3 by 7 is 21 times 2 gives us 42 square inches there. We add those up and we do have 138 square inches. There's a lot of other ways you could have cut it up. You could have cut it, some people might have cut it here and here and still use the trapezoid for that. One way to do it. Yep. Oh. Since it's symmetrical, that would work. Yep. Okay. I think what I'm going to do is I'm going to give you guys a packet to work on. In this packet, pages 1. I am severely dyslexic this morning. 174 to 177. The problems in the gray, I have to do them all. Yeah, we've only got 22 minutes. Let's get into this.